On October 23, 1929, a single derrick on the 74th floor of 405 Lexington Avenue began cranking 27 tons of steel through a hole in the roof. 90 minutes later, the Chrysler Building was the tallest structure ever built by human hands. The architects of 40 Wall Street across town had thrown a celebration just weeks earlier, convinced they had won the race to the sky. They had no idea that William Van Alen had been hiding a 185-foot spire inside his own building, assembled in secret across 7 floors, waiting for this exact moment. The derrick that raised it was rated for 20 tons. The spire weighed 27 tons. And we are going to tell you exactly how they pulled that off, along with every machine, every contractor, and every rivet that built what many consider the most beautiful skyscraper ever constructed. This is the story of the machines that built the Chrysler Building. To understand why the Chrysler Building was built the way it was, we need to start with the men behind it, and more specifically, with a feud. William Van Alen was born on August 10, 1883, in Williamsburg, Brooklyn. He studied at Pratt Institute and then at the Atelier Masquerade before winning the 1908 Paris Prize, which sent him to study at the prestigious École des Beaux-Arts in France. A colleague once called him the Ziegfeld of his profession. He was flamboyant, creative, and obsessed with ornamentation. In 1911, he formed a partnership with another architect named H. Craig Severance. Van Alen was the creative visionary. Severance was the business rainmaker. Together, they built a successful practice. But by 1924, the partnership had fallen apart in what both men described as an irreconcilable split. They went their separate ways, and within 5 years, they would be locked in one of the most dramatic architectural rivalries in American history. The project that became the Chrysler Building started not with Walter Chrysler, but with a real estate developer named William H. Reynolds. In 1927, Reynolds commissioned Van Alen to design a tower at 405 Lexington Avenue, targeting a height of 808 feet with a glass dome at the top to create the effect of a great jeweled sphere. It was ambitious, but Reynolds ran out of money before construction could begin. That was when Walter Chrysler stepped in. On October 15, 1928, Chrysler bought the entire package from Reynolds for over $2.5 million. The lease, the plans, and the architect all came with it. Chrysler had made his fortune building automobiles, and he wanted a headquarters that would announce his name to the Manhattan skyline. He told Van Alen to make it taller. Van Alen redesigned the tower to reach 925 feet. Then came the complication. Across town, at 40 Wall Street, Van Alen's former partner H. Craig Severance was designing his own skyscraper for the Bank of Manhattan Trust. In April 1929, Severance announced that 40 Wall Street would reach 840 feet, making it the tallest building in the world. The race was on. What followed was a series of chess moves that played out in real time across the Manhattan skyline, with both architects adjusting their designs upward even as construction was already underway. Van Alen raised his target. Severance raised his. Van Alen raised again. At one point, Severance added a flagpole to his design, purely to gain extra feet. The newspapers covered the rivalry like a prize fight. The two men who had once shared an office were now trying to humiliate each other with steel and concrete. Chrysler reportedly signed a blank check and told Van Alen to do whatever it took to win. Van Alen responded by designing the chrome crown and secretly obtaining a building permit for a spire that would push the building past 1,000 feet. He told almost no one. The plans were kept in a locked office. Workers at the building site were given only the information they needed for their immediate tasks. A friend of Van Alen's later claimed the arch concept for the crown was inspired by a bottle of Bacardi. though Van Alen never confirmed this. Severance, meanwhile, believed he had won. 40 Wall Street held a public celebration when it topped out, announcing itself as the world's tallest building. Newspapers ran the story. But Van Alen had already begun assembling his secret weapon inside the Chrysler Building's own skeleton. Severance would not learn the truth until he read about it in the newspapers. But before any of that could happen, someone had to dig the hole. If you enjoy videos like this one and want to see more deep dive construction history, hit like and subscribe so we can keep making them. Foundation work began in mid-November 1928. The general contractor was Fred T. Lay and Company, based in Springfield, Massachusetts. Fred T. Lay himself had risen from rodman on a survey crew to head one of the largest construction firms in the United States. His biggest project before the Chrysler Building was Camp Devens, later renamed Fort Devens, which he built as a military installation in 1917. His company had also constructed the United States Post Office in Springfield, and Lay was known for maintaining personal control over every major project rather than delegating to superintendents. Lay's crews excavated down to bedrock at 69 feet below street level, deeper than the Empire State Building's 55-foot foundation. They punched through layers of soil and quicksand, using timber-lined caissons sunk by hand excavation. The quicksand was a particular problem. Workers had to pump water continuously while digging inside the caissons to prevent the sidewalls from collapsing inward. Each caisson was a rectangular timber box open at the bottom that was weighted and sunk progressively deeper as workers excavated material from inside. When bedrock was finally reached, the caisson was filled with concrete to form a permanent pier. The numbers are staggering. Workers removed 105 million pounds of rock and 36 million pounds of soil. That combined material weighed 63% of the finished building's total weight. They were pulling more than half a skyscraper out of the ground before they could start building one on top of it. And all of this had to happen on a cramped midtown Manhattan lot, with Lexington Avenue traffic flowing past the site perimeter and the 42nd Street IRT subway tunnels running directly beneath. The structural engineering firm was Ralph Squire & Sons, led by William Ralph Squire. Squire had been born in 1871 and had formerly worked at Post and McCord, the same company that would erect the building's steel. He founded his own practice in 1913 and had previously engineered the original Ebbets Field in Brooklyn. The building sits on a trapezoidal plot because its east wall follows the path of the old Boston Post Road, a colonial-era route that predates the 1811 Manhattan Street grid. With the foundation in place, the steel erection could begin. And this is where the story becomes an equipment story. The first steel beam went up on March 27, 1929. Carnegie Steel Company of Pittsburgh supplied all 20,961 tons of structural steel. The logistics of getting that steel from Pittsburgh to a cramped midtown Manhattan lot were an engineering challenge in themselves. Steel was shipped by rail to yards in New Jersey, then transferred to trucks for delivery across the river. Trucks arrived at the site on a strict schedule because there was almost no room for staging material on the ground. Each truck had to be unloaded immediately by the relay derricks. If a truck arrived early, it waited on Lexington Avenue. If it arrived late, the derrick crews above stood idle. The coordination between the rail yard dispatchers, the trucking companies, and the site foreman had to be precise, because every hour of idle derrick time cost money and slowed the pace of 4 floors per week that Fred T. Lay had committed to. Otis Elevator Corporation was contracted to install 32 elevators, arranged in 4 banks of 8. But during construction, temporary material hoists carried tools, mortar, bricks, and small supplies up the building's core. These hoists ran continuously from dawn to dusk, and they were among the most dangerous pieces of equipment on the site, because workers frequently loaded and unloaded materials from open hoist platforms, while the building shook with the impact of riveting hammers above. The steel erection contractor was Post and McCord, a division of American Bridge Company. They were the undisputed leaders of high-rise steel erection in late 1920s New York. A 1933 trade advertisement confirmed their portfolio with 3 words: Empire State, Rockefeller, Chrysler. Post and McCord erected both the Chrysler Building and the Empire State Building within a year of each other, using essentially the same equipment and many of the same men. Understanding how they built the Chrysler Building is understanding how they built the Empire State Building, because the 2 projects were functionally one continuous operation. No tower cranes existed in 1929. Hans Liebherr would not invent the modern tower crane until 1949. Every one of the 20,961 tons of Carnegie steel reaching the 77th floor of the Chrysler Building got there by guy derrick. A guy derrick is a vertical latticed steel mast held plumb by 6 or more wire rope guys anchored to the building's own steelwork. A luffing boom hinges at the base and swings using a bull wheel. They look primitive by modern standards. They were the most powerful vertical lifting machines available in 1929. Post and McCord deployed 2 types: relay derricks, fitted with 75-foot booms and 82-foot masts, were positioned on cantilevered platforms extending from the building face. Their job was reaching down to street level, picking steel directly off delivery trucks, and swinging loads to staging areas or passing them upward to the next derrick in the relay chain. As the building rose past its setback floors and the working face retreated from the street, these relay derricks became essential bridges between ground and sky. Erecting derricks rode the rising steelwork itself. Post and McCord typically ran 20-ton units for standard beams and girders, and 30-ton units for the heaviest column sections. On the Empire State Building, they operated 9 erecting derricks simultaneously. The Chrysler Building, with roughly 1/3 the steel tonnage and a smaller footprint, likely operated 4 to 6 erecting derricks at peak activity. Each erecting derrick required a crew of 9 men. The hoisting drums held 3,500 feet of cable each, and they incorporated band service brakes controlled by levers to govern cable speed while lowering loads. The primary hoisting engines were steam-powered double-drum units, the industry standard. Clouds of steam from puffing hoisting engines were a defining sensory feature of the 1920s construction sites, accompanied by the clanging of bell signals. 1 bell to go ahead, another to stop, 2 to slack off, 3 quick ones to lower fast, 6 bells for all off. The operator worked blind, guided entirely by these bell codes from a signalman he could not see. The major hoisting equipment manufacturers supplying New York skyscraper projects in this period included Clyde Ironworks of Duluth, Minnesota, confirmed on the Empire State Building and the Golden Gate Bridge. There was also American Hoist and Derrick Company of St. Paul, Minnesota, founded in 1885, and Lidgerwood Manufacturing Company, which produced derrick hoists and cableway engines extensively used in New York construction. The most remarkable mechanical feature of the entire project was how the derricks climbed the building they were building. Every 2 floors, which the trade called 1 lift, each guy derrick would jump itself to a higher position. The August 1930 issue of Popular Science Monthly published diagrams showing the process. First, the boom was detached and laid across the steelwork. The guy wires were slackened. Then the boom was reconnected in a configuration that allowed it to lift the derrick's own main mast. Timber cribbing was erected on the new floor level to serve as a temporary base. The mast was then hoisted 2 stories upward by its own boom and set on the cribbing. Finally, the guy lines were re-anchored to newly erected steelwork. The boom was reattached in its working configuration, and the derrick was ready to resume lifting. This self-climbing technique was effectively the ancestor of modern tower crane climbing frames. It was repeated dozens of times as the building rose 77 stories. The entire jump procedure took roughly half a day per derrick, during which that derrick was out of service. Post and McCord staggered the jumps so that at least 2 or 3 derricks were always operational while others were climbing. At setback floors, where the building's footprint narrowed in accordance with New York's 1916 zoning law, corner derricks were dismantled entirely as they were no longer needed. Each dismantled derrick's components were lowered to the ground by the remaining active derricks, which added yet another task to an already demanding schedule. The pace of construction was relentless. Steel erection moved at 4 floors per week during peak operations, slightly behind the Empire State Building's later record of 4.5 floors per week, but extraordinary for a building that was charting unknown territory. Nobody had ever built a structure this tall. Every floor above the previous world record of the Woolworth Building's 792 feet was genuinely uncharted engineering. The steel framework went from ground level to full height in roughly 6 months. The first steel went up on March 27, 1929. By September 1929, the structural steel was complete at 77 stories. Now, every one of those steel connections had to be made permanent, and that meant rivets. The Chrysler Building consumed 391,881 rivets. Every single one was heated to cherry red in a portable coke forge, thrown through open air by tongs, caught in a tin can, jammed into a pre-drilled hole, and mushroomed into permanent shape by a pneumatic hammer delivering impacts at 90 psi. The riveting gangs worked in teams of 4 to 6 men, following a choreography that had been unchanged since the 1890s. The heater tended a portable coal or coke forge on temporary plank platforms near the workface, heating rivets to approximately 1800 degrees Fahrenheit until they glowed red hot. Using 3-foot tongs, the heater threw each rivet, sometimes 50 feet or more, arcing through open air across the steel skeleton. A period newspaper described the scene. Spitting out sparks and fairly alive with heat, it sails with the curve of a comet's tail into a tin bucket. The pitcher puts it over the plate every time, and the catcher folds it in the tin mitt without fail. A missed catch was dangerous. One account describes a stray rivet striking a grocery store roof and setting it on fire. The catcher placed the hot rivet into the pre-drilled hole using tongs. The bucker-up pressed a dolly bar against the factory head from the backside, and the riveter, called the gunman, drove a pneumatic riveting hammer against the protruding stem, mushrooming it into a permanent connection. The dominant manufacturers of pneumatic riveting hammers were Chicago Pneumatic, headquartered on nearby 44th Street since 1920, and confirmed suppliers to the Empire State Building. They made the widely used Boyer line of riveting hammers. The Boyer number 60 handled rivets up to 7/8 of an inch in diameter. Ingersoll Rand was the other major supplier. Workers routinely switched positions because the pneumatic hammer's vibration was physically devastating over extended shifts. Among the riveting gangs were Mohawk Ironworkers from the Kanawake Reservation near Montreal, the legendary Skywalkers. Their tradition of high steel work began with the Victoria Bridge in 1886, when Dominion Bridge Company hired Mohawk men from the nearby reserve to help erect the cantilever span across the St. Lawrence River. The company had expected to use them only as laborers, but quickly discovered they had an unusual comfort at extreme heights, walking across narrow beams without hesitation. By the early 1900s, Mohawk men were traveling to construction sites across North America, wherever high steel work was available. By the late 1920s, a Mohawk enclave called Little Caughnawaga had formed in downtown Brooklyn near Atlantic Avenue, centered around Local 361 of the Ironworkers Union. They spoke Kanien'keha on the job, 1,000 feet above Lexington Avenue, and many brought their families to Brooklyn, creating a community that persisted for decades. After the Chrysler Building, they went on to work the Empire State Building and Rockefeller Center. If you have been watching this far, we know you appreciate the kind of deep construction history that other channels skip over. Hit like and subscribe so we can keep digging into stories like this one. While the riveting gangs hammered steel connections into place, something entirely different was happening higher up on the building, and this part of the story is almost never told. The Chrysler Building's crown was the first use of austenitic stainless steel on any American building. The steel was Krupp's Nirosta, a German word that is an acronym for Nicht rostender Stahl, meaning non-rusting steel. In the United States, it was marketed as Enduro Ka2, an alloy of 18% chromium and 8% nickel in 22-gauge sheets. The foundational patents were filed on October 18, 1912, by physicist Professor Benno Strauss and Dr. Eduard Maurer at Friedrich Krupp's laboratories in Essen, Germany. This was a material that had never been tested at architectural scale anywhere in the world. What makes this remarkable for equipment enthusiasts is that the crown could not be prefabricated. The 7 radiating terraced arches curved in compound dimensions that defeated conventional templating on the ground. Van Alen's solution was to build 2 complete metalworking shops inside the rising building itself, on the 67th and 75th floors. Workers measured the curved steel skeleton in the field, then fabricated each Nirosta panel to fit in these airborne workshops. Author David Stravitz confirmed that every cut of the stainless steel was done by hand and nailed onto the structure. The building was, in his words, virtually sculpted by hand. Approximately 12,500 stainless steel panels clad the crown, the spire, and the ornamental elements. A scaffolding of steel pipe draped with heavy wire netting encased the entire dome throughout construction, protecting workers and concealing the building's final form from public view. The 8 Eagles gargoyles at the 61st floor were designed by Chesley Bonestell, who later became famous as the father of space art, along with Warren Stratton. The eagles were inspired by the 1929 Chrysler Plymouth hood ornament, fabricated from Nirosta stainless steel, and stand approximately 20 feet tall, including their pedestals. They double as functional lightning rods. The American Society for Testing and Materials created a special inspection committee in 1929 to monitor the Nirosta panels, examining them every 5 years until 1960, when inspections were canceled because the steel showed virtually no deterioration. The crown was not manually cleaned until 1961, over 30 years after installation. Now we come to the moment that made the Chrysler Building famous: the secret spire. Van Alen described the challenge in his October 1930 Architectural Forum article. The spire was 185 feet high and 8 feet square at its base. It was made up of 4 corner angles with light angle strut and diagonal members, weighing 27 tons in total. It was manifestly impossible to assemble this structure and hoist it as a unit from the ground, and equally impossible to hoist it in sections and place them in their final positions at that height. Besides, as Van Alen wrote, it would be more spectacular for publicity value to have this cloud-piercing needle appear unexpectedly. The spire was fabricated off-site by a bridge building company, not a conventional building contractor. Bridge fabricators had the expertise for long-span lattice steel assemblies that building trades lacked. The specific firm has never been publicly identified. The spire arrived at 405 Lexington Avenue in 5 sections, quietly delivered by truck to avoid tipping off Severance's spies across town at 40 Wall Street. The relay derrick system then performed a vertical bucket brigade. At street level, a derrick hoisted each section to a setback. There, a second derrick seized it from above and lifted it higher. The process repeated until sections reached the derrick perched on the 74th floor. From there, sections were lowered down into the building's central fire tower court, an open well spanning 7 floors of the steel skeleton. The first section rested on 2 12-by-12 Yule wooden boards, 20 feet long, set as a temporary platform on the 65th floor. Some floor framing had been temporarily removed to create clearance. Inside this well, workers assembled the 5 sections one atop another and riveted them together. An American flag was attached to the top. The riveters reportedly did not fully understand what they were building until the sections came together. The secrecy was that extreme. On October 23, 1929, the derrick began the final lift. According to author Neil Bascom, the derrick was over its 20-ton rated capacity for the 27-ton load. Workers determined that at the right boom angle, the geometry might just hold. The derrick leaned its boom from an outrigger platform pressed close against the crown arches for extra bracing. Lines from the derrick were attached to the center of the spire to keep it plumb as it rose. As Bascom noted, balancing an elephant by his trunk on top of the building would have been an easier proposition. The derrick began cranking, its wheels turning, and the spire rose through the open dome. Workers on the outrigger platform rushed to grab the emerging structure and align it with the riveting holes. Riveters locked it in place with pneumatic hammers. A worker then climbed the lattice with a level to confirm the tallest structure in human history was plumb at 1,046 feet. The whole operation took 90 minutes. One day later, on October 24, 1929, the stock market crashed. The world Van Alen had built his masterpiece for was already gone. And now we come to the part of this story that most documentaries rush past: the safety record. It deserves more than a passing mention, because what happened on this project was genuinely unprecedented. Walter Chrysler personally financed the entire $20 million project from his own pocket, not through Chrysler Corporation. This was his money, his risk, and his reputation. He implemented safety measures that were genuinely ahead of their time. Protective fencing surrounded the entire site perimeter, keeping pedestrians and unauthorized visitors away from falling debris zones. Steel netting was strung between floors to catch falling workers or dropped tools. This was not standard practice in 1929. Most construction sites relied on workers' own agility to keep them alive. Tubular framed scaffolds replaced the improvised plank walkways common on other projects. A site telephone network connected foremen at various elevations to ground-level supervisors, allowing rapid communication about incoming loads, weather changes, and emergencies. A small on-site medical facility with trained first aid personnel treated injuries immediately rather than waiting for hospital transport across congested midtown streets. Consider what these men were doing every day. They walked on bare steel beams 8 inches wide, hundreds of feet above the street, in wind, rain, and summer heat. They caught red-hot rivets thrown through the air and hammered them into place with vibrating pneumatic guns. They rode derrick loads up and down the building because climbing 70 flights of ladders took too long. There were no harnesses. There were no hard hats. Hard hats would not become standard on American construction sites until the late 1930s, and even then, they were often resisted by workers who considered them uncomfortable and unnecessary. The result was 0 worker fatalities during the steel erection of the world's first super-tall skyscraper. 3,000 men, 20 months of construction, 1,046 feet of height. Not a single death during the structural steel phase. For context, the Empire State Building that followed, using the same Post and McCord crews and the same equipment, recorded 5 official deaths among 3,400 workers. The Brooklyn Bridge killed at least 27 men. The Hoover Dam killed 96. The Golden Gate Bridge killed 11. The Chrysler Building's record stands alone. Chrysler himself stated that it was the first time any structure in the world had reached such a height, yet the entire steel construction was accomplished without loss of life. Some historians have questioned whether this figure excludes workers killed during foundation work or interior finishing, since the claim specifically references steel construction. But even with that qualification, the achievement is remarkable. It suggests that Chrysler's investment in safety netting, site organization, and medical support made a measurable difference at a time when construction deaths were considered an unavoidable cost of progress. The building opened on May 27, 1930, just 20 months after groundbreaking. Tenants began moving in even before the final decorative work was complete. For 11 months, the Chrysler Building held the title of tallest building in the world. Then the Empire State Building surpassed it in April 1931, rising to 1,250 feet using many of the same Post and McCord Derrick crews who had just finished at 405 Lexington Avenue. Those men did not even have to learn a new system. They took their guy derricks, their cable drums, their relay techniques, and their riveting gangs directly from one project to the next. The Chrysler Building has never reclaimed the height record, but most architects will tell you it did not need to. Polls of architects, historians, and the general public have consistently ranked it among the most beloved buildings in New York City, often ahead of the Empire State Building itself. The aftermath for the man who designed it was devastating. William Van Alen had failed to execute a formal written contract with Walter Chrysler before construction began. This was an extraordinary oversight for a project of this magnitude, and the reasons have never been fully explained. When Van Alen requested the standard 6% architect's fee of approximately $840,000, Chrysler refused and publicly accused him of suspicious financial arrangements with subcontractors. The implication was that Van Alen had been receiving kickbacks from suppliers in exchange for specifying their products. Van Alen denied the allegations, sued Chrysler, and eventually won the full fee in court. But the damage was done. The lawsuit generated headlines in the New York newspapers, and the public association with financial impropriety followed Van Alen for the rest of his career. Combined with the Great Depression killing new construction across the country, his practice collapsed. He never received another major commission. He shifted to teaching sculpture at the Beaux-Arts Institute of Design, living quietly in relative obscurity. He died on May 24, 1954. Half his estate went to the National Institute of Architectural Education, which renamed itself the Van Alen Institute in 1996 in his honor. Today, the Van Alen Institute is a nonprofit design organization based in New York that focuses on the intersection of design and public interest. But Van Alen had one last moment in the spotlight. On January 23, 1931, at the Society of Beaux-Arts Architects Ball at the Hotel Astor, the theme was Fête Moderne, a fantasy in flame and silver. Over 24 architects came dressed as buildings they had designed. Van Alen appeared dressed as the Chrysler Building itself, wearing a crown of sunbursts and a metallic cloak, while others wore generic tunics. It was the last time he publicly celebrated his masterpiece. During construction, Van Alen also filed U.S. Patent 1,794,809, titled Windowsill, on September 18, 1929. The patent covered a Z-shaped non-corrosive metal windowsill designed to protect mortar joints from weather deterioration on brick-clad buildings, directly applicable to the Chrysler Building's 3,826,000 hand-laid bricks. There are a few facts about the Chrysler Building that most documentaries miss entirely. Cooper Union has owned the land beneath the building since 1902. As a tax-exempt educational institution, Not a single dollar in property taxes from the Chrysler Building has ever gone to New York City. The ground lease payments go entirely to Cooper Union. The building contained a speakeasy. The Cloud Club was an exclusive private lunch club on floors 66 through 68. It featured Tudor-paneled rooms, a Renaissance marble staircase, and during Prohibition, a barber shop and locker rooms that concealed alcohol. Members included Pan Am founder Juan Trippe, publisher Condé Nast, and boxer Gene Tunney. Walter Chrysler had his own private dining room with a frieze of automobile workers. The club closed in the late 1970s and was gutted for offices. The lobby features 50 figures modeled after actual construction workers, clinchers, surveyors, masons, carpenters, plasterers, and builders who worked on the project, immortalized in wall panels that most visitors walk past without a second glance. And the spire's interior is industrial reinforced concrete, not the Art Deco elegance of the exterior. Author Moses Gates described the experience of climbing inside. You think of the Chrysler Building as Art Deco, shiny, chrome, metal. You get inside, and it is all reinforced concrete. In 2019, the building sold for $150 million, down from $800 million in 2008. The Chrysler Building was not built with exotic machines. It was built with Guy derricks, steam hoisting engines, portable coke forges, and pneumatic riveting hammers, the same equipment used on dozens of lesser buildings in late 1920s. Manhattan. What made it extraordinary was how those machines were deployed. Self-climbing derricks that caterpillared upward 2 stories at a time using their own booms. Metalworking shops operating at the 67th and 75th floors, where stainless steel panels were hand-cut to fit curves that could not be templated on the ground. And a single overloaded derrick that raised a 27-ton spire through the building's own roof, 7 tons past its rated capacity, in 90 minutes flat. Post and McCord took their derricks, their 3,500-foot cable drums, and their relay techniques directly from the Chrysler Building to the Empire State Building, making the 2 projects one continuous operation by the same steel erection crew. The equipment was ordinary. The ironworkers, engineers, and Mohawk skywalkers who operated them 1,000 feet above Lexington Avenue were anything but. If you want to see how those same machines and men built the Empire State Building, that documentary is already on our channel. Like and subscribe so you do not miss the next episode. We will see you there.